Hello students, so let us see some more applications of pressure in day-to-day life. We have nails, keel and screws, pins. All these nails, screws and pins, they have very sharp, pointed ends. Now why this is so? You can do an activity. Take a nail or a pin. The pin is like this. It has got a head and it has got a very pointed edge or end. You take this pointed end inwards towards the wall and the head towards you, and then you hammer it. In this case, when you apply this formula, you will see that area at which you are applying the force, because the pointed end is on the wall and on that pointed end you are applying force. Because that area is very low, very small, therefore the pressure is very high. And because the pressure is very high, that nail goes into the wall or the wood, whichever the case is. Now you do reverse of this. Take this pin and now place the head of the pin on the wall and the pointed end towards you. Now you hammer the pin. There is no chance the pin will go into the wall, because the area that is the head of the pin, you are applying force on it. The area is large and therefore the pressure applied on the pin is too low. It won't go in. Let us see another application. The railway track you all must have seen. It is kept, the long rails which are made of iron, they are kept on wooden or concrete or cement slabs. If this is the rail, this is the iron rail, you will see that these are the wooden, very broad, wooden or concrete or cement planks which are below that rail. Why this is so? Let us apply the formula. Pressure is equal to force upon area. Because the force is very high, the train is so heavy. If the area on which the train runs, if the area below this rails, below this iron pieces is small, the pressure will be so high that it will be difficult for the train to move. Therefore, we want to reduce this pressure applied on the railway track. To reduce this pressure, we either have to decrease this force, but we cannot decrease the force because the weight of the train is fixed. We cannot do it. So what we can do it is, this small area we can make it larger. And if this area becomes large, the pressure will decrease to some extent. And to increase this area, we put this large, broad slabs These slabs are normally made of cement or wood. This is why on a railway track we put wooden, concrete or cement slabs. Let us see one more application. Battle tanks. Which are very heavy. Tanks which are used in warfare. You must have seen those tanks, they are very, very heavy. These battle tanks are made to run over chains and not wheels. Again, let us apply the same formula. Pressure is equal to force upon area. Because force is very high, again to reduce pressure we want to increase the area. And if this battle tank runs on wheels, the area of contact will be very small. And if the area of contact will be small, the pressure will be huge. And if it moves on sand or if it moves on water, it will get into it. It will not be able to move. Therefore, what we do is to increase the area and therefore to decrease the pressure, we make it to run on chains which are very broad. And once it runs on chains, you must have seen even in movies, or actually if you have seen tanks moving, it can move on any surface, even on sand. When we walk on sand, what happens? Because of the force, because of our weight, because our feet have a small area, our feet get entangled into the sand. And similarly, if a battle tank which is much more heavier than us, if it moves on sand, it will not be able to move. Therefore, it is made to run over chains. Let us see one more application. All of us use knives, scissors, blades. All these, they have very sharp, pointed edges. Why is it so? Because in this case, we want a very high pressure. If you take an apple and you try to cut that apple with a knife, but the opposite end, which is blunt, which has a larger area, you will see that you will not be able to see that apple. You will not be able to cut. Why? Because the pressure is low. Why that pressure is low? Because the area on which you are applying force is large. And when this area is more, this pressure will be less. To increase this area, we make the edges very sharp and pointed, and therefore the area is reduced. When this area gets reduced, the pressure becomes high so that it can cut vegetables and fruits. The same is the case with scissors and blades. Let us see the next application. The rear tires of heavy trucks, you must have seen trucks, and in the front they have 2 tires, in the back they have either 4 or 6 or 8 tires, multiple tires. That is because the load is at the back which they are carrying. And so that the pressure they apply on the ground is less, they can move easily. So that the pressure is low, they need to increase the area of contact. And to increase this area of contact, they have these multiple tires. More the number of tires, more will be the area on which they will exert force. Let us see the application in case of buildings like dams and very tall buildings. In case of very tall buildings, buildings which have maybe 50 or 100 floors. Nowadays it is a trend that very tall buildings are made because of shortage of space. And in case of these very tall buildings, because the amount, this is the ground level, because this building is very tall and it has number of floors, it is made of concrete, iron, rods. Therefore, it is a very huge structure which is very heavy. And because this is very heavy, the force is enormous. And therefore, what we do is the foundation of this building is much wider than the width of the building. This is the width of the building and this is the width of the foundation below the earth. And because this foundation is very wide, what we are doing is we are increasing the area on which force is applied. And because this area on which force is applied is very large, the pressure will be reduced to some extent. And therefore there are less chances of collapse of this building during earthquakes or any other calamity. Another application is that of dams. In case of dams, dams are also very huge. And the foundation of these dams also is much wider. Now this is the ground level. Therefore initially when the dam or a building is built, it is the foundation which is dug. And this foundation when it is dug, it is so wide that the force is very large. We increase the area of contact, area on which this force is acting. And because the area on which force is acting is also very large, therefore it reduces the pressure. These are all the applications of pressure in day-to-day life. Thank you.